Dear students, today we are discussing heat. Okay, in heat part, how many questions are asked in previous years? For example, problem here. If you see this graph, process one, what type of process it is? Like this. It is just like a bar. It is just like a bar. So the process two, which is like this. Okay, okay. So this is process one. This is process four. So process 4, if you observe, process 4 is a bar. So process 4 is going to be isobaric process. Okay. Next process 2, if you observe, this is process 2. So what type of process it is? This is called as adiabatic process. Adiabatic process. So process 2, this is going to be process 2. Process 2 is going to be adiabatic process here. Okay. Next, after that, we shall go for isothermal process. Okay, this is an isothermal process. So process 3. So what is this process 3 here? Process 3 is going to be isothermal process here. Okay, constant. Here volume is going to decrease. So when V is constant, what type of process it is? Isochoric. Isochoric. This is isochoric process. This is isobaric. This is isochoric. This is isochoric process. Next, this is adiabatic process, and this is isothermal. Isobaric, isochoric, adiabatic, and isothermal. Here, pressure and volume are going to change very slowly. Pressure and volume are going to change very slowly. Whereas in adiabatic, sudden decrease in pressure takes place and sudden increase in volume takes place. If the process is sudden, it is called as adiabatic. If the process is slow, pressure and volume changes slowly, and this is having another name also. What is that name? You know, it is also called as quasi-static process, where the process takes place very slowly. Understand? This is a very slow process. This is a slow process. This is a fast process. Okay, and this is isobaric. This is isochoric. So, what is process 1 is C, process 2 is A, process 1 is C, process 2 is A, process 3 is D, and process 4 is B. So correct option is A option. Okay, A option is correct option, which is asked in 2017 here. Okay, then it's a very simple problem. Okay, then we should, and what type of molecule this is? Hydrogen. Hydrogen is considered to be H2. Helium is considered to be He, and another ideal diatomic gas whose molecules are not rigid but move in additional vibrational models. That means this is going to be poly. Okay, this is going to be mono, and this is going to be dia. Okay, so the first one is going to be hydrogen, which is called as dia, and second one is going to be monoatomic, and this is X, which is called as polyatomic. So how are you going to solve this problem in a very easy manner? It's very simple to do this problem. I'll show you this formula. So what are you going to do here? Gamma is equal to 1 plus 2 by F, where F is called as degrees of freedom. Where F is called as degrees of freedom. So let us consider first of all hydrogen. So this is a diatomic molecule where degrees of freedom is going to be 5 here. So first one, if you observe, that is 1 plus 2 by F, which is equal to 1 plus 2 by 5. So your answer is going to be 7 by 5. Then second option, if you observe, helium. Helium is going to be monoatomic. Helium is going to be monoatomic. This is helium. Helium is going to be monoatomic. So what is the formula going to write now? It's very simple. So 1 plus 2 by F, and here for monoatomic molecule, degrees of freedom for monoatomic molecule is 3. For monoatomic molecule, degree of freedom is going to be 3. That's why you write here, that is degrees of freedom, gamma value is equal to 1 plus 2 by F, which is equal to 1 plus 2 by 3, which is equal to 5 by 3. Next, third one. What is third one? X, which is having one vibrational model also. It is having vibrational motion also. That means it is going to be polyatomic. Okay, a diatomic gas having vibrational model also, then it is called as polyatomic. So if it is a polyatomic, this is called as polyatomic. For X, here degrees of freedom, F is going to be 7 here. Why 7? Why 7? Because it is having 3 translational kinetic energies, 3 rotational kinetic energies, and 1 vibrational kinetic energy. 1 is extra here. So for X, it is having vibrational model also, whose molecules are rigid but have additional vibrational models. So here degrees of freedom for a polyatomic molecule which is also having vibrational model means it is having 3 translational kinetic energies, 3 rotational kinetic energies, and 1 vibrational kinetic energies. Understood? So therefore, what are you going to do now? You just take degrees of freedom for X is going to be how much? It is going to be 7. Therefore, gamma is going to be 1 plus 2 by 7, which is equal to 9 by 7. Okay? So this is the options here. So what are you going to get the options here in this case? So this is second one. Your answer is going to be 7 by 5, 7 by 5, 5 by 3, and 9 by 7. Okay? So first one is 7 by 5. This is 5 by 3, and this is going to be 9 by 7. So first option is going to be the correct option. So this is the problem, state 1 to state VT graph. Okay, what is asking? The ratio of work done, the ratio of work done to the heat absorbed. So what he is going to ask for us? Just see the ratio of work done. That means he is asking us to find out dW by dQ is how much. Okay, so we have to find out what is dW by dQ. How are you going to find out this dW by dQ? I'll tell you a small technique for this. Okay, so let us solve this problem. Okay, so we should first find out what is dW. So you know dW, first thing is dW is nothing but force into displacement, and you know pressure is equal to force by area. Force is equal to pressure into area. Force is equal to pressure into area. So pressure into area into dx, and you know area into length is equal to volume. So here area into length is going to be dx means dv you have to consider. So therefore dw is equal to p into dv. Okay. Then after that what is written? pv is equal to rt when n equal to 1 mole. pv is equal to rt when n equal to 1 mole. So this can be written as pdv can be written as r dt. So therefore you can write dw is equal to r into dt here. Then how are you going to find out dq? Okay, so d here cp is considered as 5 by 2 r. cp is considered as 5 by 2 r. So 5 by 2, this is 5 by 2 r into dt. dq is equal to 5 by 2 r into 5 by 2 r into dt. Whereas what is dw? So this is going to be this one. Then after that, after finding these two, what are you going to do here? dw means you'll write r dt, and dq is nothing but 5 by 2 r into dt. So dt gets cancelled, rr gets cancelled. So your answer is going to be 2 by 5. Okay. So in this way, you can find out the problem. So what is the correct option in this case? You just see. So your correct option is going to be the second option, 2 by 5. Okay, as this is going to be 2 by 5 here. Understood? So how many problems we have done nearly? So this is a shortcut table. How are you going to solve this shortcut table? So monoatomic molecule means 3 translational kinetic energies. One is X. See, monoatomic molecule, see, having 3 translational kinetic energies, x-axis, y-axis, and z-axis. 3 translational kinetic energies. Diatomic molecule means 3 translational kinetic energies and 2 rotational kinetic energies. In this way, x, y, and z, 3 translational kinetic energies. Rotational kinetic energies means if this is a diatomic molecule, with this as an axis, it will rotate like this, and with this as an axis, it will rotate like this. So 2 rotational kinetic energies and 3 translational kinetic energies. So degree of freedom is 5 here. In this case, it is 3. Now here, it is a triatomic molecule or it is a polyatomic molecule in which it is having 3 translational kinetic energies, 3 rotational kinetic energies, 3 rotational kinetic energies in this case. Okay, as it is a 3 atomic molecules. Okay, So it's having polyatomic or triatomic, you can say. So it is having 3. So total degree of freedom is 6 here. So you know internal kinetic energy is given by F by 2 RT. Internal kinetic energy is given by the formula which is called as F by 2 RT. Understood? Therefore, here you can write this as 3 by 2 RT. This is 5. So 5 by 2 RT. This is 6. So 6 by 2 RT, which is equal to 3 RT. Next, if you consider CV, CV is nothing but du by dt. So du by dt means this t gets cancelled here. Du by dt means dt by t gets cancelled. So answer is f by 2 r. So 3 by 2 r. Here this is going to be 5 by 2 r, and this is going to be 3 r. That's it. Because here dt and t gets cancelled here. Dt and t gets cancelled here. If you want, I will show you here. Because CV is equal to du by dt. So d by dt of u, which is equal to f by 2 rt. So f by 2 is equal to f by 2 into r is equal to dt by dt gets cancelled. So what is left here? F by 2 r is left. So this is f by 2 r. Understood? That's next. You just see Cp is equal to Cv plus r. Cp is equal to Cv plus r. So what are you going to know? What are you going to do here? So Cp is equal to Cv plus r, and Cv is nothing but f by 2 r plus r, which can be written as f by 2 plus 1 into r here. So f by 2 plus 1 into r. So what are you going to do here? F by 2 means degree of freedom is 3. So 3 by 2 plus 1 into r, which is equal to 5 by 2 r. Here in this case, f by 2 plus r means what are you going to write here? F is 5 here. So f by 2 plus 1 into r. This formula you have to apply here. So you're writing 5 by 2 plus 1 into r. So which is equal to 7 by 2 r. Here it is going to be how much? What is the degree of freedom here? 6. So here f by 2 plus 1 into r if you write. So this is going to be 6 by 2 plus 1 into r. So how much it is going to be? 3 here. So it is going to be 4r in this case. So like this you will write now. So du by dq is how much? 1 by gamma. And dw by dq is 1 minus 1 by gamma. So it's like this you can completely fill up the table here. So this table if you fill up, it is equal to 18 problems. I'll show you how to fill this table in just a small screen here. If you want to understand the background of this table, I will explain it on a small screen so that it is convenient for you to understand. Kinetic theory of gases and thermodynamics combined together. Kinetic theory of gases and thermodynamics, because these two chapters are interrelated with each other. Okay, so if you learn, this is going to be a 10 minutes to 20 minutes video where you can learn 50% of kinetic theory of gases and 50% of thermodynamics in this chapter. Okay, so you can learn 10 minutes to 20 minutes. It will take 50% KTG you learn, 50% thermodynamics you learn. I'll tell you all shortcuts, so don't go anywhere. Be with me and learn 50% to 50% in a very easy method and a shortcut methods. Thank you very much. Stay with me. So first thing is why we call internal energy as RT by 2. Okay, why we call internal energy as RT by 2? For example, if you consider internal energy as U, if you consider internal energy as U, it is called as RT by 2. Why? It is according to equipartitional law. You know that I have told you just now, equipartitional law. First thing is we should know what is work here. You know, work done is equal to force into displacement, and you know pressure is equal to force by area. Okay, so force is equal to pressure into area. Therefore W can be written as pressure into area into displacement, and you know area into length is equal to volume. Area into length is equal to volume. Therefore area into length can be taken as V here. Okay, it can be taken as V. And you know PV is equal to RT. You know PV is equal to RT when N is considered to be 1 mole here. Okay, so therefore W can also be taken as RT. W can also be taken as RT. It can also be taken as energy as RT, and it can also be taken as internal energy as RT. But according to equipartitional law, it is said that internal energy for each and every degree of freedom, internal energy for 1 degree of freedom is considered as RT by 2. Therefore, instead of R by RT, we need to consider the internal energy as RT by 2 here. But what is CV? How are you going to find out CV here? You know the basic formula here. What is the basic formula? Do you know? The basic formula for quantity of heat is ms delta T in case of macroscopic bodies. For example, quantity of heat is directly proportional to mass. Quantity of heat is directly proportional to rise in temperature. But in the case of for gas, the formula little bit changes here. If you consider the internal energy of a gas, it can be taken that du is equal to, instead of taking m, you have to consider n. Instead of taking s, you have to consider specific heat at constant volume. And instead of delta T, you need to consider dt here. Okay, you need to consider dt here. So for example, n equal to 1 mole here, n equal to 1 mole, then what happens to du? Du is equal to Cv dt. Therefore, Cv is equal to du by dt. Understand? Cv is equal to du by dt. So, by seeing these two formulas, you will come to know a conclusion that Cv can be taken like this, as internal energy is equal to RT by 2 according to equipartitional law. Therefore, and here I told you that Cv is equal to du by dt. Cv is equal to du by dt. You can take Cv as d by dt of RT by 2. Therefore, Cv can be considered as R is constant, R by 2 can be taken outside. You can write dt by dt. Okay, so you can write like this. Therefore, internal energy can be considered as how much? It is Cv is equal to R by 2. Okay. Okay. See, this is for 1 degree of freedom. This is for 1 degree of freedom. See, if it is a monoatomic molecule, you know degrees of freedom is equal to 3 here. Degrees of freedom is equal to 3. Therefore, instead of writing R by 2, you can take there as Cv is equal to nR by 2 here. Cv is equal to nR by 2. Therefore, here as n equal to 3, Cv considered as a 3R by 2. And for diatomic molecule, how much is Cv here? So as Cv is equal to nR by 2, and for diatomic molecule, you know degrees of freedom is considered to be 5 here. So therefore, Cv can be considered there, okay, Cv can be considered there as 5R by 2, 5R by 2 for a diatomic molecule, and this is for a monoatomic molecule. Now let us go for triatomic molecule or a polyatomic molecule. Triatomic or a polyatomic molecule. So where degrees of freedom is considered to be 6 here. Okay. So degrees of freedom is considered to be 6 there. Therefore, you can write Cv is equal to nR by 2. Okay. nR by 2. What is n here? Number of degrees of freedom. So number of degrees of freedom is considered to be 6 here. Understood? Number of degrees of freedom can be taken as 6. You can take degree of freedom as n or f, whatever it may be. So therefore, Cv can be considered as 6R by 2. Therefore, it can be taken as 3R here. So Cv for triatomic molecule is taken as 3R. Then next we shall discuss about triatomic molecule with vibrational kinetic energy also. If vibration is also mixed, then what happens to degrees of freedom? Degrees of freedom, that is n, r, it can be taken as f also, doesn't matter. So that is going to be how much? It is going to be 7. How is it so? The meaning here is the degree of freedom is going to become 7. It is a special case where vibrational kinetic energy is also mixed here. So 7 means 3 translational kinetic energies, 3 rotational kinetic energies, and 1 vibrational kinetic energy is also mixed. So therefore, completely it is going to become 7 as degrees of freedom. Therefore, Cv for triatomic molecule having with vibration is also considered as 7R by 2 here, because the formula is Nr by 2 or Fr by 2, where N and F are called as degrees of freedom. Understood? See, generally we take F here because N is considered to be number of moles. Therefore, you may get confusion. So, generally in kinetic theory of gases, degrees of freedom is considered to be F here. So, therefore, Cv is equal to 7R by 2 here. Next, how to find out Cp? How to find Cp? Okay, so here you know the concept, that is Cp minus Cv is equal to R. Cp minus Cv is equal to R. This is the basic concept here. So from this basic concept you'll understand Cp is equal to Cv plus R. Cp is equal to Cv plus R. And you know Cv is equal to Fr by 2 here. Fr by 2. And you also know that du is equal to Frt by 2. Okay. Why it is Frt by 2? As I said here, internal energy for 1 degree of freedom is considered to be RT by 2. For F degrees of freedom, it can be considered as FRT by 2. Understand? Degrees of freedom is considered to be FRT by 2. Whereas CV can also be considered as NR by 2, or it can also be considered as FR by 2 here, where F and N is considered as degrees of freedom. Therefore, now internal energy is FRT by 2 here. And okay, then how are you going to find out Cp in this case? So Cp is equal to Cv plus R. You know Cv is equal to Fr by 2 plus R. So therefore, Cp is considered as F by 2 plus 1 into R. This is the formula for Cp here. Got the point now? So therefore, Cp, you got the basic formula. Now we shall discuss about how are you going to find out the next part of this table, that is delta U by delta Q, delta W by delta Q, and delta U by delta Q. How are you going to find out? See, if you know these values, so 1, 2, this is from thermodynamics. These formulas are from thermodynamics. These formula for kinetic theory of gases. Combine together 2 chapters you learn in one table here. It's a very simple process where you learn how are you going to find out all these things. Okay, so now let us see how are you going to find out delta U by delta Q as 1 by gamma, delta W by delta Q as 1 by 1 minus 1 by gamma, and percentage also you are going to find out now just in simple methods. So just now I told you that this table is equal to 18 problems. Understand? 9 problems from kinetic theory of gases will be covered. 9 problems from thermodynamics also covered. As I explained on the monitor screen, the previous year problems, that type of problems you can get in future also in coming this 2020 paper also. That's why I'm discussing the shortcut table which will help you to solve the problems here. Now we will fill up these columns, but before going to the fill up these columns, we should have some basic knowledge here. So we shall go for the basic knowledge which we are going to discuss now. See here. Now what we need to find out first thing is, it is called as delta U by delta Q. How are you going to find out all these things? We shall discuss here. And we need to prove that either you can take delta U by delta Q, or you can take du by dq. You should prove that it is going to be 1 by gamma. Then how are you going to do this one? We shall discuss one by one. Okay, so let us start this one. So now du by dq means what? You know general formula is Q is equal to ms delta T. Internal energy, it can be taken as NCV dt, because specific heat at constant volume. Okay, CV means volume is going to be constant here. CV means at constant volume we can say. And similarly the same formula can be used for dq also. Then where dq is equal to NCP dt, because at dq Cp is going to be considered here. Specific heat at constant pressure we can consider. So Cp is nothing but specific heat at constant pressure here. Okay. Now you just see here, if n equal to 1 mole, you did not consider n in this case. Understood? Now let us see how are you going to solve this problem. First thing is, you should find out the values of Cp and Cv. You have to find out the values of Cp and Cv. How are you going to find out the values of Cp and Cv? You just see here, you know Cp minus Cv is equal to R here. Okay, Cp minus Cv is equal to R. Next, what are you going to do? Divides both by Cp. Understand? And you should know one more value, that is gamma is equal to Cp by Cv. It is a basic formula, everyone knows about this. Now let us go for the derivation here. So in this case, divide both by Cp. So here Cp by Cp minus Cv by Cp is equal to R by Cp here. So Cp by Cp is equal to 1. This is, as gamma is equal to Cp by Cv, then Cv by Cp is equal to 1 by gamma here. So you can just take here 1 by gamma, which is equal to R by Cp. Therefore, gamma minus 1 by gamma is equal to R by Cp. This implies that by doing cross multiplication, you will get Cp is equal to gamma into gamma into R by gamma minus 1. So this is going to be the value of Cp here. This is going to be the value of Cp here in this case. Okay. Next, we shall find out the value of Cv. So just now we got the value of Cp in terms of gamma here. Next, we shall discuss the value of Cv also. Cv in terms of gamma here. How are you going to find out Cv in terms of gamma? For that, the basic formula is the same. Cp minus Cv. Cp minus Cv is equal to R. Okay. But in this case, divide both with Cv. Previously we have divided with Cp, but you have to divide with Cv. Then what are you going to get in this case? Let us see. What are you going to get in this case? Let us see here. So therefore, Cp by Cv minus Cv by Cv is equal to R by Cv. Therefore, gamma minus 1 is equal to R by Cv. So Cv can be considered as R by gamma minus 1. R by gamma minus 1. So therefore, we got the values of Cp as well as Cv now. So Cp I got here Cp. I'll write here Cp value. Cp is equal to how much? Gamma into R by gamma minus 1. And we got the value of Cv also. Then how are you going to find out the first ratio in this table, that is delta U by delta Q, or du by dq, both are going to be same as I said here. For that, what you need to do, let us see here. So du by dq you need to find out. So how are you going to find out this value? Let us see. How are you going to find out this value? Let us see. So you all know du is equal to n cv dt and dq is equal to n cp dt here. Okay. So what are you going to do this? Here du by dq you have to write. Du by dq means what are the things going to be cancelled here? So n is going to be cancelled, n dt gets cancelled here. What is left now? Cv by Cp is left. Cv by Cp is left, which is nothing but 1 by gamma, here. So this is the value of delta U by delta Q. If he asks percentage of du by dq, then you just do one thing. 1 by gamma into 100 you have to do. 1 by gamma into 100 you have to do here. Okay. So next thing which we need to find out is delta W by delta Q you have to find out. Delta W by delta Q you have to find out. So let us find out the value of delta W by delta Q, or it can also be called as dW by dQ. So how are you going to find out this value here now? It's very simple, very easy to find out the values of this. Now first thing is delta W by delta Q. So delta W is R dt or NR dt, okay, whatever it may be. So dQ means what? What are you going to consider dQ here? See, dq means ncp dt. You just write ncp dt. So nn gets cancelled, dt gets cancelled. So dw is equal to dq, which can be taken as r by cp. Okay, r by cp. But what is the value of cp here? What is the value of cp? You just see here. What is the value of cp? You just write here the value of cp here. That is r by gamma r by gamma minus 1. So rr gets cancelled. So dw by dq is equal to gamma minus 1 by gamma. Okay, so gamma minus 1 reciprocal by gamma. So this can also be written as 1 minus 1 by gamma. For example, he is asking us to find out percentage of dw by dq. You can write gamma minus 1 by gamma into 100. Okay, so like this we are going to get here. Okay, so we got the values of even dw by dq also. Percentage of dw by dq also we got here. Understood? That is 1 minus 1 by gamma. Okay, 1 minus 1 by gamma. And if you want to find out the percentage, 1 minus 1 by gamma into 100. Okay, so like this you have to find out here. Then now, so I can take gamma minus 1 by gamma or 1 by 1 minus gamma. So you can take dw by dq is equal to 1 minus 1 by gamma into 100. Also you can write. You can take this formula or this form, doesn't matter here. So if once you know the complete derivation, that means you have completed thermodynamics basics also, and you have completed the basics of kinetic theory of gases also. Next, how to fill up this table? That is a big question before us. You need to fill up this table now. Okay, so you know the value of gamma here. How are you going to find out the value of gamma? First thing is, so once you know the value of gamma in all these three cases, it's very simple to find out the value of delta u by delta q. Okay, so how are you going to find out the value of gamma here? Understand? So it's very simple to find out the value of gamma. Let us discuss the value of gamma in separate page here. Okay, so here we shall discuss the value of gamma. You know that gamma is equal to cp by cv. Okay, gamma is equal to cp by cv. We have derived one concept in the previous page here. What is that? Let us see. So we have derived here. Understood? So gamma is equal to r by gamma minus 1. Cp is equal to gamma by gamma minus 1. These two values you have derived. Either you can take these two values, or you can take the values which have been derived in the case of kinetic theory of gases here. If you observe kinetic theory of gases, you know the values of Cv and Cp. What are the values of Cp and Cv according to kinetic theory of gases here? You just see. So here, just now you got that Cp is equal to how much? F by 2 plus 1 into R. Yes, F by 2 plus 1 into R, as we have derived here. Next, you know the value of Cv also. Cv value is nothing but F by 2 into R here. Then gamma is equal to Cp by Cv. Then how are you going to find out the remaining values here? It's very simple. You just write here F by 2 plus 1 into R divided by F by 2 into R. So RR gets cancelled here. Then what is left? Gamma is equal to, this is, you can take an LCM here. So you'll get F by 2 whole divided by F by 2. This is getting cancelled now. F by F plus 2 by F here. Therefore, this implies that the value of gamma is equal to F by F plus 2 by F here. So gamma is equal to 1 plus 2 by F. Like this we got the value of gamma here. So if it is a monoatomic molecule, what happens? And if it is a diatomic molecule, what happens? So you know, just now in the problem I have discussed the values here. If you want, you can just go through that problem also. So gamma is equal to 1 plus 2 by 3 for monoatomic molecule. For diatomic molecule, gamma value is going to become 1 plus 2 by 5, because their degree of freedom is 3, here degree of freedom is 5. Similarly, if it is a triatomic molecule or a polyatomic molecule, you know gamma is equal to 1 plus 2 by F. Okay, 1 plus 2 by F. Where for triatomic molecule it is going to be 6. So gamma is equal to 1 plus 2 by 6. We have done there. Okay, so like this we can find out the values of gamma here. So then you can just fill up this table slowly one by one. Okay, so you can write the table, try to complete this table. If you complete this table, you know everything now. Gamma values also you know, gamma values also you know. Then once you know the values of gamma, you can fill up the table by yourself. This table if you fill up and keep with you, then it will be very simple for doing any problem.